talking about accelerated motion. Now, when will an object be accelerating? Acceleration means speeding. Is that right? You put your foot on the accelerator, the speed of your car increases. So when the speed increases, you are accelerating. When the speed decreases, also you are accelerating. When the speed increases, you have positive acceleration. When the speed decreases, you have negative acceleration. Or let us say that acceleration occurs when velocity changes. Now, objects moving with uniform or constant velocity is not very common around us. All the objects that we see moving are sometime or the other accelerating. Now, when you put your foot on the accelerator, the speedometer of your car shows how the velocity of the car changes. Is that right? How the speed of the car changes. Now, the pointer moves from 0 to 10, 20, 30, 40. It tells you the speed of your car is increasing or you are accelerating. So, when the velocity of a moving object changes, we say it has an acceleration. So, acceleration is caused by a change in velocity. And how do you measure acceleration? Acceleration is a measure of the rate of change of velocity. You see, we have been talking about the rate of change a lot, is that right? Now, how do we write acceleration equal to the rate of change of velocity? Can you write that down as a mathematical equation? Well, we can write acceleration equal to change in velocity divided by time. Now, change in velocity, and what is the time taken for that change in velocity? Let us say the velocity in the beginning, when you start looking at an object, is VI, initial velocity. And after a certain amount of time, t seconds, the velocity became VF, final velocity. Tell me, what is the change in velocity? The change in velocity is the final velocity minus the initial velocity. So, can you write what acceleration is? The change in velocity is Vf minus Vi, and therefore acceleration can be written as acceleration equal to change in velocity divided by the time taken for that change in velocity. Now, if Vi is the initial velocity and Vf is the initial velocity, and I'm going to use this time delta t as the time, the small change in time. So, our change in velocity is Vf minus Vi, and shall we call it delta V? Well, you know what does delta V stands for. Delta V is the change in velocity. So, if A is the acceleration of the object, this change in velocity occurs during this change in time. So, you have acceleration equal to Vf minus Vi divided by delta t. And let's now write Vf minus Vi equal to delta V, right? So, acceleration is delta V divided by delta t. Now, obviously, it tells me that if you draw a graph of velocity against time, the slope of that graph will be acceleration. Is that right? Delta V is the change in velocity. Delta t is the change in time. So change in velocity divided by the change in time is the rate of change of velocity. So what is the unit of measuring acceleration? Anybody tell me the unit for measuring acceleration? What is the unit for change in velocity? Now remember, the unit of change in velocity and the unit of velocity is the same. Is that right? The unit for money and the unit for change. You see, if I had $20 in my pocket, I spent $5 out of it. What is the change in the amount of money that I have now? Well, the money in my pocket has been changed by $5. So the change also is measured in the same unit. So if velocity is measured in meter per second, the change in velocity also is measured in meter per second. So change in velocity is measured in meter per second. Change in time is measured in second. What is therefore the unit of acceleration? The unit of acceleration will be meter per second divided by second. Now how will that look? Let me write that down here for you. Meter per second divided by second. The unit of change in velocity is meter per second and the unit of time is second. And you know that becomes meter per second times second. And that will be meter per second squared. The unit of acceleration is meter per second squared. All right. Okay, let me take that away from the screen. Now, look at the way I'm going to write this equation now. If A equal to delta V divided by delta T, and if I multiply both sides by delta T, I will get delta V equal to A times delta T. It's the same equation. Delta V equal to A times delta T. Now, this equation is similar to Y equal to mx, and we have been talking about it in our last lesson. So, what that tells you is, if you draw a graph of velocity on the vertical axis and time on the horizontal axis, the slope of that graph will give you acceleration. That's what this equation means. So, y, the delta v, the change in velocity or velocity, velocity stands for y and time is in the position of x, and then acceleration is in the position of slope. So, what will be the shape of the graph of velocity against time? A graph of velocity against time will be a straight line, and the slope of that straight line will be acceleration. Alright? So, let's draw a graph of velocity against time. I will give you an exercise. Now, this is what I did. I measured the velocity of a trolley in intervals of 1 second. Well, you can see I have a trolley in here, and we will be using this soon to do an experiment. You can see this trolley, I used this trolley here. Can you see this trolley moving? Alright. I used this trolley and measured its velocity in intervals of 1 second. And I have tabulated those values for you. Now, when time is 0, the velocity is 0. When time is 1 second, the velocity is 10 meters per second. When the time is 2 seconds, the velocity is 20 meters per second. When the time is 3 seconds, the velocity is 30 meters per second, and so on. I have 6 trials. Can you use these values to draw a graph of velocity on the y-axis, time on the x-axis, and measure its slope. Alright, I want you to hit pause on the video and do this exercise. Do this graph, velocity on the y-axis, on the vertical axis, time on the x-axis, and measure its slope, delta v divided by delta t, and that will be a measure of the acceleration. Okay, alright, let me show you the graph I did. Now this is the graph I did. You can see when time is 1 second, the velocity is 10 meters per second. When the time is 2 seconds, the velocity is 20 meters per second. The time is 3 seconds, the velocity is 30 meters per second. The time is 4 seconds, the velocity is 40 meters per second. So you have a straight line, and what does the slope of the graph represent? The slope of the graph represents the acceleration of the car. Alright, so the graph is a straight line and its slope is the constant acceleration. Now, acceleration is a measure of the slope of the graph. I'm going to take 2 points. Now that's what we do. Take 2 points on the graph in order to calculate your slope. Alright, I'm going to take this point. What is the name of that point? Its x value is 2, y value is 20. The second point I'm going to take is the x value 4, the y value 40. In other words, the first point, the time is 2 seconds, the velocity is 20 meters per second. The second point, the time is 4 seconds, the velocity is 40 meters per second. Alright? What is the change in velocity here? How did I get the change in velocity? Look at this. At this point, the velocity is 40 meters per second. And on our first point, the velocity is 20 meters per second. Therefore, the change in velocity, delta v, is 40 minus 20, that is 20 meters per second. Let's find the change in time. Now, the time for the second point is 4 seconds. The time for the first point is 2 seconds. The change in time, delta t, is 4 minus 2 equal to 2 seconds. Therefore, what is the slope? Acceleration is, the slope is delta v divided by delta t. Change in velocity divided by the change in time is 20 meters per second divided by 2 seconds equal to 10 meters per second squared. The acceleration of the car I just experimented with is 10 meters per second squared. Alright? Okay. Now, you know that if the velocity is uniform, what is the meaning the velocity is uniform? Velocity is uniform means each second the increase in distance is the same. Each second the car travels the same distance. So if you draw a graph of position against time, distance against time, that will be a straight line. Is that right? Yes. Now watch this again. If I have an object traveling like this, now each second the change in positions are exactly the same. This is where you start. After 1 second it is here. After the second second it is over here. The third second, fourth second, the change in positions are the same every second. So, if you draw a graph of distance against time, we did that in the last class, distance against time, that will be a straight line. Because for each increase in time, you see, when time equal to 1, the distance is 2 meters. When the time is 2 seconds, the distance will be 4 meters, and so on. Now, what happens if the object is accelerating? An object accelerating means each second the distance it covers will be greater and greater and greater. Now, for an accelerated object, if it starts here, after 1 second it is in this position. After the next second it may be traveling a lot more distance. At the end of the next second it may be traveling a lot more. You see, in the first second the car travels that much. In the second second the car travels a lot more. In the third second the car travels a lot more. So can you tell me, if I draw a graph of x, the distance against time for this, what kind of a graph will that be? Well, any idea how that's going to look like? Well, let me show you that one more time. Now, we start here. After the first second the car is there. After the second it is gone a lot more. After the third second, now if you draw a graph of x on the vertical axis and time here, let me show you this. Now this is 2 meters. In the next second it has traveled, let's say, 7 meters. And in 3 seconds it has traveled 15 meters. So at the end of the first second, this is where the object is. At the end of the second it has traveled, if this is 4, this is 8, that will be 7. You see, at the end of the second. So, at the end of the first second, our car traveled a distance of 2 meters. At the end of the second it has traveled a distance of 7 meters. It is here. At the end of the third second, it has traveled a distance of 15 meters. Where do I mark that 15? It will be somewhere over here. And so you can see the graph is going to curve up. So, if an object has a positive acceleration, the graph of distance versus time will curve up. If the object has no acceleration, if the speed is uniform, the distance against time will be a straight line. Alright? Now you need to understand that in order to understand the motion of objects. Okay, so the graph of position against time of a car moving with uniform velocity will be a straight line. On the other hand, if a car is accelerating, what will the position against time look like? Alright, it will be a graph that curves. What do you think about it? Alright, look at the motion of a car in the positive x direction with a constant velocity. Alright, I'm going to illustrate this one more time. Here I have a car moving with a constant velocity. Look, each second the change in position is exactly the same. Constant velocity. And look at the graph of position against time. It is a straight line. And you can see the velocity does not change. The velocity remains a constant. That means there is no acceleration. So an object that is moving with uniform velocity, you see how beautiful it looks? Every second the change in position is the same. That means position increases with time uniformly, a straight line. The velocity remains uniform, remains a constant, and there is no acceleration. Its graph of position versus time is a straight line, and the slope of this graph will give you the uniform velocity. That's what we did in the last class. Now, since the velocity is a constant, that slope is a constant. I want you to now look at a car moving with an acceleration to the right. All right, watch this. Each second, the change in position is greater and greater and greater. Is that right? Yes. This is acceleration to the right. Now look at the position against time graph. It is a curve that is curving up. That means the velocity is continuously increasing. You got an acceleration. So the position versus time curves up, telling that the position changes greater and greater and greater each second. Let's now talk about the cause of acceleration. Anybody tell me, what is the cause of acceleration? What will make an object accelerate? Well, the behavior of all objects can be described by saying that objects tend to keep on doing what they are doing. You see, if an object is at rest, an object at rest wants to keep on being at rest. An object in motion wants to keep on being in motion. It doesn't want to be interrupted. That is the law of nature. Every object wants to keep on doing what it is doing. If you are sleeping, don't you want to keep on sleeping? Well, I don't think you want to extend that to any other things. Is that right? Okay, so I don't want to go there. Now, Newton described this in a statement that I'm going to give you. Newton said, every object, an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless, in the same direction, unless acted upon by an unbalanced force. So the only thing that can change the state of rest or the state of motion of an object is an unbalanced force. Now you can see the moment I drop this has an unbalanced force. Now where does the unbalanced force come from? It is the pull of gravity by the earth. That is the unbalanced force. Now, in the previous experiment you did, the unbalanced force, I actually pulled the car with a force to make it move. So, once again, what is the law that Newton said? An object at rest tends to stay at rest. The tendency of an object at rest is to stay on being at rest. And an object in motion tends to stay in motion. The tendency of an object in motion is to keep on moving. Now, what will change this? An unbalanced force. Only an unbalanced force can change the state of rest of an object. Only an unbalanced force can change the state of motion of an object. Now, this statement is called the first law of motion. So, if I ask you, what is the first law of motion? What will you tell me? Very simple. You could tell me, if an unbalanced force does not act on an object, if an object is at rest, it will keep on being at rest. If an object is in motion, it will keep on being in motion. That is the first law of motion. Now that means, if all the forces are balanced on an object, that object will, if the object is at rest, it will stay at rest. If an object is in motion, it will stay in motion. Now, the only way to change this is to apply an unbalanced force. Let's talk about now inertia. Now, this is actually inertia. You see, the tendency of an object to keep on doing what it is doing is called inertia. An object doesn't want to change. You see, you don't want to get up in the morning. That's an inertia. You want to keep on sleeping. The tendency of an object to keep on doing what it is doing is called inertia. Now look at this. Why is this man doing like this? Can you tell me, give me an explanation for this? You can see the car and the man is in motion, isn't it? And something in motion wants to keep on being in motion. The car was suddenly brought to a stop. Did the man stop? No. The man wants to keep on moving. So you can see a good illustration of inertia. So once again, the man and the car are actually moving. And the car is suddenly brought to a stop. But because the man is not wearing a seatbelt, he has inertia. He wants to keep on moving, and he does so. Look at that. All right. How about another animation? I think I have another animation. Look at that. Again, the man and the motorbike are moving, and suddenly the motorbike is brought to a stop. Well, the man has inertia. He wants to keep on moving. Beautiful illustrations of... So, another one. Look at this one. Have you seen this happen? Yes. The truck and the ladder are moving together. If the truck is suddenly brought to a stop, the ladder will keep on moving. The ladder was moving before, it wants to keep on moving. So, these are all examples of inertia. So, in the absence of an unbalanced force, an object in motion will maintain the state of motion. So, this is often called the law of inertia. So, the first law of motion, Newton's first law of motion, is also called the law of inertia. Let's now talk about Newton's second law of motion. Tell me, what does the first law of motion tell you? Newton's first law? Newton's first law tells us that an object wants to keep on doing what it is doing unless an unbalanced force acts on it. And that law is called the law of inertia. Let's talk about Newton's second law of motion. Now, when an unbalanced force is acting on an object, what does that unbalanced force do? It is an unbalanced force that produces an acceleration. You see, the moment an object at rest begins to move, its velocity is changing, therefore it is accelerating. The moment a moving object is brought to a stop, its velocity has been reduced from a certain value to zero. It is accelerating. So, if an unbalanced force is acting on an object, that unbalanced force will create an acceleration. So whenever there is an unbalanced force, that unbalanced force will produce an acceleration. So if I ask you again, what is responsible for producing acceleration? Well, acceleration is produced always by an unbalanced force. That means an unbalanced force acting on an object will produce an acceleration. Alright, now look at the forces on this man. Is there any unbalanced force on him? Well, you see, the earth is pulling him downward. Actually, the pull of earth on an object is called the weight of the object. So the gravity is pulling him down, and the ground is applying a force to support it. You see, when I'm holding this block in my hand, the gravity is pulling it down and my hand is supporting it. That means I am applying a force upward, and these two forces balance each other. We say there is no unbalanced force. Therefore, this man will happily stay there with the happy sign or the victory sign, whatever he's doing. That's right. No unbalanced force on him. This block has no unbalanced force. Therefore, it will not accelerate. But, well, you know what a car do. You put your foot on the accelerator, you actually produce a net force. So while the forces on the person are balanced, there are unbalanced forces on the car which will accelerate the car. An unbalanced force will always produce acceleration. Be very sure about it. An unbalanced force will produce acceleration. So if I ask you, what will an unbalanced force do on an object? What's your answer? The unbalanced force will produce acceleration on the object. And the acceleration is proportional to the unbalanced force. What does that mean? Acceleration is proportional to the unbalanced force. It means you increase the unbalanced force, the acceleration will also increase. Is that right? That's what it means. So the acceleration is proportional to the unbalanced force, and it is in the direction of the unbalanced force. And actually, this is the statement of Newton's second law. So what does Newton's second law say? Newton's second law says an unbalanced force acting on an object will produce an acceleration on it, and that acceleration is proportional to the unbalanced force. You increase the unbalanced force, the acceleration will also increase. A more powerful car can go from 0 to 90 in a very short time. It can produce a much greater acceleration. Is that right? When the unbalanced force is greater, the acceleration is greater. Now, this statement is Newton's second law of motion. So you must be familiar with both statements of Newton's laws. Now, if F net means the net force or unbalanced force. This is a way of writing it. F net is the unbalanced force on the physics book. You can see? Now, the force of gravity on the book is balanced by the force applied by the table. So there are no unbalanced force in the vertical direction. But I'm now going to pull the book horizontally with the force, giving it an acceleration. Just like now, here I have the block sitting on the book. Is that right? You can see that. Now, there are no unbalanced force on it now. What happens when I pull it to the right? You can see the unbalanced force I'm producing on the block is producing an acceleration. Okay, so if F net is the unbalanced force on the physics book, and M is the mass of the book, Newton's second law can be written as, I'm going to write down Newton's second law as an equation. F net equal to ma. You see, this is what Newton's second law says. Acceleration is proportional to force. When you represent that as an equation, this is how it looks. I want you to remember this equation. The unbalanced force F net equal to mass of the object times its acceleration. Now, a greater net force produces a greater acceleration. Alright, let's see see what the unit of force is. Something you must know very well. What is the unit of force? Now, unit of force is made up of unit of mass and unit of acceleration. Tell me, what is the unit for measuring mass? Mass is measured in kilogram. Alright? What is the unit for measuring acceleration? Acceleration is measured in meter per second squared. Okay, now tell me, what is the unit for measuring force? Therefore, we will measure force in kilogram meter per second squared. Look at that. The unit of force is kilogram meter per second squared. And since it is a long quantity like that, kilogram meter per second squared, we're going to give it a name. Its name is the Newton. So we will use the uppercase N to represent that. The unit of force is called the Newton. And the Newton is a kilogram meter per second squared. What does that mean actually? It means if I have a car of 1 kilogram, suppose I have a car of 1 kilogram, and I want to produce an acceleration of 1 meter per second squared on this car, the amount of force I need to apply is 1 Newton. That's what it means. The amount of force that will produce an acceleration of 1 meter per second squared on an object of mass 1 kilogram is called 1 Newton. 1 Newton is 1 kilogram meter per second squared. Okay, let me ask you a simple question now. What is the net force on a 1,000 kilogram car that accelerates at 5 meter per second squared? I have given you the mass, I have given you the acceleration, I want you to find the net force. Alright, can you do that? Very simple. What is the second law equation? F net equal to ma. That's what we want to find. We want to find the net force. So that will be mass multiplied by acceleration. That will be 1,000 kilogram multiplied by 5 meter per second squared. That will be 5,000 Newton. That is the unbalanced force on the car that produces this acceleration.